Hey everybody, this is continuing the review 4.3 to 4.4. We're now on the 4.4 type questions, and the first one says identify the coordinates of any local and absolute extreme points and your inflection points. So the first thing you're going to want to do on this, if you can, is factor. And so this would be y equal, starts with x. We need 35 and we need negative 12. So this would have to be a 7 and a 5. And because it's negative 12, then both of these have to be negative. So by doing that, you will know where your x-intercepts are. So 7 and 5 are x-intercepts. Okay. The next part is you want your derivative. And of course I would take the derivative back from the original, so that's going to be 2x minus 12. And so if you factor that out, that 2 out, which is your GCF, and see that 6 would have to be a minimum or a maximum. And in this case, because it's positive x squared, it's going to be a minimum. So basically, somewhere along this line is going to be your minimum because it's got to open up. Okay. Now, if we go back to the original, and graph that, x squared minus 12x plus 35. Look in your table, and there's 6, negative 1. We could have also done it from the normal thing. Menu, analyze, minimum between here and here gives you 6, negative 1. Okay. So we can plot this there. And 3 points should be adequate to graph it on the computer. Just make sure you have those 3 points. If you really wanted to, you could have, done more. I'm going to start with what we had: 5, 0, 6, negative 1, and 7, 0. Another one I guess I'll use is at 3, it's 8. And so if I look in my table in the y column for 8, that's at 9. So 9, 8. Or you can just think a certain amount over to the left and to the right. So that's going to be your graph. 9, 8. Okay. So the next part of this is, well, we do not have a local maximum based on the graph, so that's B. The local minimum is 6, negative 1. There's no absolute maximum point. The absolute minimum point is the same as what we said earlier, 6, -1. And then if it's quadratic, there are no inflection points. You would have to have x cubed or greater. So that's pretty much it for that. We already graphed it, and then we have our answers. Okay. For our next one, this is 4, 4, 13. And basically going to do the same type thing, except I'm not going to bother trying to factor that, because it's harder in this case. But I know my y prime would be -2 times 3 is -6, and lower x cubed to x squared, and then 6 times 2 is 12, and so this is 12x. So there's your y prime. Now we can factor out a -6x from that to give us x minus 2. Checking that, -6x times x is -6x squared. -6x times -2 is a positive 12x. So what that tells you is that 0 and 2 have something important happening there. So that's probably your local max and min. We're going to have to graph it to see which one, but that's going to tell you what we want for that. We're also going to do the double prime, and the double prime helps you for your inflection point. And so y double prime would be -6 times 2 is -12, so -12x plus 12. So on that one, if we factor out our -12, we get x minus 1. So that means x equal 1 is the inflection. Okay, so now we can start to put everything together. We're going to want to graph the original. So go into here, -2x up arrow 3 plus 6x squared minus 6. There's your graph. And so 0 looks like it was a minimum right there, and 2 kind of looks like it'd be a maximum. So let's use those points to graph. So I want to go a little bit to the left. I don't want to use -234, that wouldn't make sense. I want to use -1,2. So -1,2 is here, 0, -6 is down here. This is my minimum. And then 2, 2, this is my maximum. And then after that it falls again, and I don't want to use 4, -38, so I'm going to use 3, -6. So it's basically going here, then up, then down, and continue, and this can continue going this direction. Okay, so I started here, I went down to my minimum, up to my maximum, continued through this, and then I extended this one. Okay, so that's what we want, and now you can label your points. Your local maximum is the 2, 2. Your local minimum is 0, -6. You do not have an absolute max or min. No absolute max or min, because it just continues. It continues going down, it continues going up. So just local. Just locals. And then the next part is about the inflection point. So earlier we thought x = 1 would be the inflection. And this is the part where you need to be a little careful. Well, I guess 1, -2 is in my table, and that's the correct answer. But when I drew this freehand, it looked like it was 1, 0. So that's where you got to be careful and use your number that's actually in your table. You can call it inflection or POI, and that's 1, -2, just based on that. So again, as a reminder, the point of inflection is basically where it changes from being concave up to concave down. This one was concave up, and this one is concave down. And so this is an example of one where if I had to make a generalization, I would say it's usually halfway between your min and max. Usually halfway between your min and max. So your minimum was at 0. Well, think of it this way. This one was at 0 and 2, so half would be 1. And this would be between -6 and 2, so half would be -2. So it's halfway between both the x and y. So it's half of the x and y. It's like the average. So there you go. Okay, so that means that over here where it says the inflection points are, and over here I put x = 1, this is going to be 1, -2. Okay, so now we're done with that one. And the next one is 4, 4, 21. And on this one, we're going to want to find our coordinates of the local and absolute extreme points and the inflection. Now, looking at this one, you have your original equation, and they already factored out the x to the 4th from the first two terms for you, and then have a vertical shift down of 4. I was going to say a downshift, like a downshift of 4. So this one's a little bit more challenging than this one that we did, just because of the downshift, so to speak. But what you're going to do is you're going to take your derivative and then factor out and so forth. So for y prime, that would be 5x to the fourth minus 40 x cubed. Now that one looks like a good one to factor out, a 5x cubed, and we would get x minus 8. So when we set that equal to 0, then 0 and 8 would be things to look at for locals. At this point, I don't know if they're minimums or maximums. Then for the y double prime, this would be 20x cubed minus 120 x squared. Now, why this is good to do this way by hand is because sometimes your window may be off and not show you everything. Like you might have to expand it or whatever. This one looks like a good one to factor out also. So let's factor out a 20x squared. So we get x minus 6. So that tells me that 0 and 6 would be interesting for those. And since we already had a 0, I'm going to throw that out. And this one's going to be your point of inflection. So let's see if all that makes sense and check our work. You know, we're not always right the first time, but let's learn from it. But I think that's going to be right. Because if we already had 0 that would be a local min or max, then it cannot be a POI also. So let's try that. So graphing the original. X up arrow 5 minus 10 x up arrow 4 minus 4. Okay, so it's just showing me a little bit. See, this is what I was saying. We know something should happen at 8. And so what we don't know is how low it goes. So I'm going to do menu for A, and well, now that's a little weird. Let's do the analyze graph and go to the minimum over here, between here and here. And I see at 8 it's this value, negative 81.96. So looks like based on that, 8 comma negative 81.96 looks like it's going to be a minimum, and if you plug in 0, you're going to have negative 4 for your max. You can look in your table, you can like find it like this. On the graph to the naked eye it looks like 0, 0, but it's not. It's 0, negative 4. So you could do it that way. You could look in your table, because we already knew we were interested in 0 and 8. So there's a few different methods. You know, do what's fastest for you. For me it'd probably be the table, but for you it may be something else. We said 6 could be your point of inflection, and we know from the table that being 6 comma negative 51.88. Okay, so let's fill all that information in. So for your maximum, it's 0, negative 4. For your minimum, it's 8, negative 81.96. This one does not have absolute max or min, so no absolutes. The reason is because the graph continues. It continues down and it continues up. So we don't have absolutes like we do on quadratic. Now remember, I don't want to generalize too much, but on cubics usually have either one absolute minimum or maximum. Actually, let me not generalize. You usually have one local min or max. Anyway, let's say this is no absolute max, this is no absolute min. Then we already figured out our inflection point was 6, negative 5188. And that's the A graph, where it had a really low value down here for 8, negative 8196. So that's how you know what graph it would be. Okay, so then going on to this one. This one is like 4429. Oh, this is one of the easy ones, like really easy. Okay, so let's graph it. It's x to the 3/5. Well, I really should say f, or f1. Remember that would be like the 5th root of x cubed. That's how it's related. The denominator is really the root, and then this is really the power. So let's graph it. X up arrow 3 divided by 5. Okay, well it's like that. And so if it's like that, then, well, that's a bad sketch, but this is basically going to be 0, 0 for your point of inflection. So this one has no local max or min, and no absolute. So this is like no absolutes. That was no absolutes and no locals. And then the point of inflection was 0, 0. If you want to look in your table, Control T, you can verify that it goes through 0, 0. And that's the graph that starts low and goes up, like this. It starts low and goes up. Okay, so that's 4429. And then on our next one, this is like number 33. You have 2x minus 3, I'm reading this one, 2x minus 3x to the 2/3 on this one, which had a cusp, which meant no inflection points. On this one, we've got 8x minus 9x to the 8/9. So the first step is to do your derivative, which would be 8 minus, okay, you take your 9 times 8/9 x and then lower it by a whole number. So 8/9 minus 1 is the same as 8/9 minus 9/9, which is negative 1/9. Okay, and so that simplifies. The 9's cancel, so you get 8 minus 8x to the negative 1/9. Then we're going to need our double prime also. And so we take our 8, and then that derivative would be 0. And then we're going to do negative 8 times negative 1/9. X, lower by a whole number again, so in this case negative 10/9. So this would turn into positive 8/9 x to the negative 10/9. So let's graph that. And we're also going to need to get our other values. Okay, so let's graph it. (8x minus 9x up arrow 8/9). Okay, so that's the cusp type problem. And so let's find out what happens at 0. Okay, at 0 it's 0. So 0, 0. So 0, 0 is a local max, because that's where the line connects to the curve. So that's what we mean there. And so you put local max is 0, 0. And then local min would be right there. It's probably 1, negative 1. Let me just double check on the analyze. And it says 1, negative 1, so it is. So 1, well, I can just put it over here. 1, negative 1. Edit, analyze, graph, and min. Okay, minimum. And then this would not have an absolute max, because it just keeps on going up and up and up. And it looks like it wouldn't stop here either for the minimum, so you'd have no absolutes. So then we put this as B for no absolutes, and this is B for no absolutes. And there's no inflection either. So there's no inflections on cusps. So that's just something to remember. So you don't do your halfway thing for the cusp. And you know it's a cusp because it's like a sharp turn and connects a line and a curve. And so that's the A graph in my case. Okay, so that was the A graph. Now for our last one, looks like you want to do your derivative of the derivative, so the second derivative for number 53. And let's see. Okay, yeah, this is the one where you need to use the product rule for your derivative, for your second derivative. And so we're doing the derivative of x, which is 1, times x minus 9 squared plus x times the derivative of this would be 2 times x minus 9 to the first, which we don't usually put, times 1, which we don't usually do because the derivative of x is 1. And so then this is like x minus 9 squared plus 2x, x minus 9. So this is one where they want you to factor by grouping. And the reason is because you've got an x minus 9 here and here. And so we do x minus 9, and then we need another x minus 9, and then plus 2x. And so this turns into x minus 9 times x plus 2x is 3x minus 9. Then what you want to do is factor out this 3, and I would put it in front of everything. We usually do that. And then this turns into x minus 3. Because 3 times x is 3x, 3 times 3 is 9. Okay, now that's going to be your equation, 3 x minus 9, x minus 3. And then when you're looking at the graph, choose the graph with 3 and 9 as special things. So let's graph it. Let's see, this has a negative, so it wouldn't be this one. These graphs go out to 14. It's probably this one, but let's graph it. Your y max is 900. Now what are we looking for? We want the graph of the general shape of f. Okay. The graph is of f, not f prime or f double prime. So that's why it's a little bit trickier than just like, oh, let's find the graph. So let's use some of our knowledge from what we did before. When we did the derivative, so from y prime, we have x times x minus 9 squared. We set that equal to 0. So 0 and 9 would be your points, and we gotta test it. So if we do x times parentheses x minus 9 squared, and look at our table, we need to the left of 0, which is negative. Between 0 and 9 is positive, and to the right of 9 is also positive. Okay, so what that means is you're going to have a local min at 0 and no local max. So that's a local minimum because you're going from negative to positive. Okay, and we've already done that part. So if you have a local minimum at 0, that's got to be the C graph, and so that's what's going to help us to graph it. Local minimum at 0, 0, and no local maximum. Okay, hope that helps.